Okay. Hello, my dear students. Hope you're all doing good. Good morning, everyone there. Right. So we have enough people, I guess. We have 11 people here. Right. So I think we are good to go. Right. We'll start. Right. Okay. Let me share my screen. So the points table looks like this, right? Okay. We have group 1 to have 16, 17.5, group 2, group 3 has 22, and group 4 has 20.75, right? So let me add a page. This is 12, 1909. Right? So let me make the table again. Group 1, group 2, group 3, group 4. Group 1 I think has 16. Group 2 had how much? Guys, group 2 has how much? Group 3 has 22. Group 3 has 20.75. How much is group 2? 20. How much?
17.75.
17.75. Okay, right. Okay, let's start with the questions. So I told you today, group 15, 16, and 17, but majority questions will be from group 17, right? So let's start. Okay, group 1, your question is why halogens are color. You have 2 minutes to answer. So why halogens are colored? I know, right? For example, chlorine is a greenish yellow gas, right? Iodine is a brown liquid, right? I think Br2, I forgot to put the color. Anybody knows what is Br2's color? Br2, anybody knows its color? What? Reddish blue.
Sir, BR, sir. Bromine.
Br
Brown, sir.
Brown. Okay, this is also brown. Okay, right. F2 doesn't have F2. I think in some form it can have color, but you don't have to worry about it. So I can understand, right? All these are colored, right? Why halogens are colored is the question.
Sir?
Yeah.
Sir, halogens, I think they have low ionization energy, sir.
Halogens have low ionization energy. Fine, okay.
Sir, because when we move down the group, the color is decreasing, sir, from fluorine to iodine. Therefore, the valence electron will be excited because of the external region of beam of it, sir. Light.
Okay.
Therefore, this reflected light, imparts the color, sir.
Okay.
Because from fluorine to iodine, atomic radius increases because iodine is largest halogen atom, fluorine is smallest, sir. So atomic radius increases, sir. So the energy levels become closer, sir.
Okay.
And therefore, on moving across the group, color deepens, sir. Like we'll get more color, sir. From fluorine to iodine, color will increase.
Understood. So yeah, it's pretty easy to understand. Say it's not about ionization energy. As you said, the levels of energy levels get closer and closer, right? So now one electron is here. It can easily go to the excited state. This is ground state, GS. This is ES, excited state. Now it can easily go to the excited state by absorbing some energy. Okay, now this energy will be in the form of a visible light. Okay, this energy will be in the form of a visible light. Okay, now why see, I'm just telling you how any compound can have color, right? So it absorbs energy, the electron goes back to the goes to higher energy level, and it will come back. It will not stay there for a longer time because it's unstable, right? Here, if it stays, it's going to be unstable. So it will come back. When it comes back, it is going to release some energy. Say this is E1, this is E2. It will not be same E1. This whatever is absorbed will not be released. That there's no point. Okay, so what you understand is, if for example, if I absorb violet color, right, you will see that the compound will be green in color, right? There's something called as complementary colors. Okay, violet and green are one such things. Okay, right? So if it absorbs one color, the complementary color is what is going to see, because that is what is coming out, right? The electron gets excited by absorbing some energy, and it get de-excited by releasing some energy. What it releases, that is what is the color of the compound you see in general. Okay, so yeah, the whatever you said was absolutely right. So you get 2 points. Right.
So could
Next
you
question.
once again just repeat the answer, final answer?
Yeah. So what happens is, basically the halogens absorb energy and the electrons gets excited. Okay. Now when they de-excite, they are going to, or I would say, I'll tell like this. Whatever some color of light, that is energy, is absorbed and the electron goes to the higher energy level, right? And when it de-excites, the complementary color of what was absorbed, the complementary color is going to get liberated, released, right? That complementary color is the one which imparts the color to the compound. Whatever the color which you see is coming out, that is what is the color of the compound you see. Yes, understood?
Yes, sir, understood.
Okay, right. Okay. Next question to group 2. Okay, group 2. I have ICl4 minus. What is the shape? And tell me, like, I have to send me in WhatsApp, right? Draw the structure, right? And mention the shape for ICl4 minus. Group 2, it's your question. I'm looking at WhatsApp. Yes, any answers, group 2? I didn't get any WhatsApp yet. Yes, any answers? Can I go to group 2? Sorry, group 3? First of all, group 2, anyone is there? Guys?
Yes, sir.
Yes, sir.
Okay. So yeah, can I go to group 3? You have any answers?
Yes, sir.
Okay, group 3, your chance. Quickly.
So just 1 minute, sir.
Yeah.
Sir, I have sent it, sir. Sir?
Yes, I got it. Got it. So yeah, okay, the structure is fine. What is the name of the shape?
Sir, square planar.
Yeah. Okay, correct. Right. So yeah, I'll do the structure now. It's very simple, people. Right. So now, how do you decide this? First, you have to decide the hybridization. Right. Okay. Or what you have to understand is in hybridization, whenever these kind of compound comes, right, the negative charge goes to bonding atom. 1 second, guys. Right, negative charge goes to bonding atom, and if I have a positive charge, it goes to central atom. Right, now in this case, now not only in this, any kind of structure you see in general, right, negative charge goes to bonding atom, positive charge goes to central atom. In this case, central atom is iodine, bonding atoms is chlorine. Right, so I have a negative charge, so obviously the negative charge goes to chlorine. Okay, fine. So we'll try to understand how the Lewis dot structure looks like. Okay, fine. Now iodine has 7 valence electrons, right? So now 1, 2, 3. Okay. 1, 2, 3, 4, 5, 6, 7. Okay, I'm just drawing something random. Okay, now what you have to understand is out of the four chlorines, 3 are chlorine atoms, right? And 1 Cl minus is present. That is how you have 1 negative charge. Okay, 3 chlorine atoms are there, and 1 chlorine ion, chloride ion is there. Right, fine. Now, if that's the case, right? Say now, well, let me draw first 3 chlorines. Say chlorine, which is going to have 7 electrons, 1, 2, 3, 4, 5, 6, 7. Right, say another chlorine I have 1, okay, 1, 2, 3, 4, 5, 6, 7. Say another chlorine I draw 1, 2, 3, 4, 5, 6, 7. Right, now 3 chlorine atoms are over. Now another one is Cl minus. Right, Cl minus means 8 electrons will be there in the valence shell. Right, so let me put it. Cl minus 8 electrons, 1, 2, 3, 4, 5, 6, 7, 8. Okay, right. Now let us do for chlorines first. Now this chlorine requires 1 more electron to satisfy its octet. So now 1 electron. Now this chlorine requires 1 more electron to satisfy its octet, and this chlorine also requires 1 more electron to satisfy its octet. No problem. This chlorine is already satisfied. Right. Okay. Now what is going to happen is this iodine is going to take up these electrons. Whatever is shared, it is going to take it. Okay. And what about this one? There is no bond here, right? What happens here? Now it's very simple to understand, people. Since I have a completely filled here, I don't have a proper covalent bond, but what I'm going to have is a coordinate. Okay, the lone pair which is there on the chloride ion is a Cl minus, right? This lone pair is going to get donated to iodine. Okay, this lone pair is going to get donated to iodine. Okay, there's a coordinate bond here. So if I draw the proper structure, right? So I will see that there is chlorine, 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 right? And there is 1 coordinate bond coming from Cl minus. Okay, and obviously you understand there is 1 lone pair here, and no, there's only 1 lone pair, right? There's second lone pair. So first lone pair, second lone pair is not involved in bonding. So iodine has 2 lone pairs. Okay, right. Now this is now when I find the steric number, we don't have to go into the details. Now this is of the form AB4L2. Right, that means 4 bonding atoms and 2 lone pairs is what you mean by this. Right, now when I have AB6 kind of molecules, I know it is going to be octahedral shape. Right, when I have AB6, say SF6, right, I know it is going to be octahedral. Right, but when I have in AB6, this is again going to be sp3d2 hybridization. This also will have sp3d2 hybridization. Okay, right. I don't want to spend some time on how it is sp3d2 on all, guys. I don't want to go into the details, but these two are sp3d2. But this is octahedral, right? Now this, if you check, octahedral shape will be like this. All these are these. Okay. Now, if I remove one bonding atom, basically I have to remove 2 bonding atoms from this, and I have to put lone pairs. Okay, now if I try to put lone pairs, it will go like this. Now I have a lone pair here, right? And there are 4 bonding atoms here. This is again my geometry. It's still octahedral. This is my geometry. Right, but when I look at the shape, as I mentioned earlier, the lone pairs must not be there. Right, if the lone pairs are not there, basically all I'm going to have is this kind of structure. Now this is what is called as square planar structure, and this is what exactly I'll have for ICL4 also. One of them will be Cl minus. That's it, and obviously it's going to be a coordinate bond. That's it. And obviously I have 2 lone pairs. Now you don't have to mention it. The shape is going to be square planar. Okay, so guys, this kind of questions will definitely come in your board exams, right? If you are finding it difficult, go back and visit chemical bonding chapter in 11th. Okay, go back and visit chemical bonding. That is going to be really helpful, right? So group 3 gets +1, right? Group 3, again your question. Okay, the question is, when SO2 is passed into a solution of an iron 3 salt solution, right? What will happen? What happens? Okay, group 3, it's your question. Okay, so what happens when SO2 is passed into a solution which contains an Fe3 plus salt? Basically, you have to give me the reaction. What happens?
Sir, it's Fe3 no, sir.
Sorry?
Fe3 no, sir.
Yeah, Fe3 plus, correct.
Sir, sulfur dioxide will act as a reducing agent, sir.
Okay, fine.
Sir,
Tell me the reaction.
okay, sir. Sir, Fe3 plus SO2. Sir, it should be in aqueous solution, no, sir.
Yes, obviously, a solid solution means an aqueous solution only.
Sir, then plus H2O should come, no, sir.
Okay.
So that will give Fe2 plus plus SO4 2 minus will come, sir.
Okay. SO4
Plus
minus
H plus. That's all, sir.
But very simple. So as he said, this is going to act as a reducing agent, right? Reducing agent, right? It will reduce Fe3 plus to Fe2 plus. And in that process, excuse me, right? So in that process, this SO2 has to get oxidized. Okay. Now SO2 will get oxidized to SO4 2 minus because reducing agents gets oxidized, oxidizing agents gets reduced. Okay, yes, it's correct. Right. Group 4, your question. Okay, group 4. Tell me, draw the structure of BrO3 minus and tell me the shape. Structure and the shape. So I mean, what's up? BrO3 minus. Yeah.
The molecular type is AB3 and its shape is trigonal pyramidal.
Wait, AB3, it is trigonal pyramidal.
Yeah, pyramidal.
Okay, fine. Can you tell me in WhatsApp how it looks?
It takes time, sir, because I don't have stable internet.
Any one of your group members can do.
Or can I show it?
1
No.
minute, sir.
Okay, you can switch on the video and show it to me. Yeah, you can do that. Right, I will see. Stop sharing. Yeah, you can switch on the video and show me. That is not trigonal pyramidal shape. And where is the positive charge coming from for Br? You have done a positive charge for Br. Where is it coming from? It is BrO3 minus. Why there is a positive charge? Oh, like unmute yourself. Unmute yourself. You're on mute.
So because of the electrons lost from here to
No, it is BrO3 minus. Bromine is an atomic state in the sense that it is a neutral state. It doesn't have any positive charge or negative charge. When I have negative charge, where it has to go?
Go to oxygen, sir.
It has to go to oxygen, right? Negative charge, bonding atom. Only positive charge, central atom.
So 1 minute, sir. Can I try and send it to you?
Yeah, quick.
So I sent a structure.
Yeah. Okay, Br. Okay, O minus. Okay, 1, 2, 3, 4. There is one lone pair. Okay, fine. That's correct. Right. So guys, when I say BrO3 minus, right? Now it's very easy to understand, right? I can draw the Lewis structure first if you want to make sure that how many lone pairs are there, right? Say Br will have 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. Right. Now there are 3 oxygen atoms, right? So 2 are oxygen atoms, normal, neutral state, and one of them is O minus. Okay, one of them is O minus. Now say, let have to rub this part. Right. One of them is O minus. Let me write it up somewhere above. Like one O minus is there. Okay, now when I take O minus here, like now oxygen has 6 valence electron, now it will become 7 because of O minus. So 1, 2, 3, 4, 5, 6, 7. Right now all the others are 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So only 3. Done. Okay. There are 2 oxygen atoms and 1 O minus, right? Now this oxygen requires 2 more electrons to satisfy its octet. This oxygen requires 2 more electrons to satisfy its octet. And this oxygen requires 1 more electron to satisfy its octet because already 7 electrons are there, right? So now you see this will be the Lewis dot structure for this particular molecule. All you have to understand is there is a lone pair here, right? So this is of the form AB3L. Okay, it's not AB3, right? But the shape you told is mentioned was correct. AB3L. This is like ammonia molecule with a lone pair. 3 bonding atoms and 1 lone pair, right? So whenever you have 3 bonding atoms and 1 lone pair, the shape is going to be trigonal pyramidal, right? It looks like this. Br double bond to O minus, and this is the shape, basically a pyramidal shape. This is a pyramid, right? Or if I write NH3, N, H, 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 and there's a lone pair. Here also there's a Br. It is. Okay, this is what is called as trigonal pyramidal shape. Okay, fine. I'll give you the point. All right, group 1, your question. Okay, the question is, right somewhere. Okay, bleaching of flowers by Cl2 is permanent, but by that of SO2 is temporary. Why? Or you don't have to worry about flowers. Don't worry about generally bleaching action of chlorine is permanent, while that of SO2 is temporary. See, when I say bleaching of flowers, right? Basically, bleaching of flowers means flowers losing their color is what I'm trying to ask you. When I say flowers are bleached, their color is lost. Flowers losing their colors is what I'm talking about.
So bleaching of flowers by chlorine undergoes oxidation.
Okay, continue.
And by SO2 it is reduction.
Okay. Okay, so your answer is right, but it is not complete. So if SO2 reduces, after that, what can happen? Say flower is there, SO2 bleaches it by reduction, and the flower is still there, then what can happen? Why is it temporary? What do you mean by temporary? That means the flower can regain the color. Is it not? How it can regain the color? If it is SO2, you tell it is by reduction, right? By reduction, the flowers will lose color, but after some time, they will regain the color. That is what you mean by temporary. Why?
I think with SO2 it forms sulfurous acid.
Okay. Fine. You have anything else to say? I'll give you 1.75 for this. But if you give me the exact answer, I'll give you 2. Yes, anything you have? Okay.
Thinking, sir.
Okay, maybe I'll give you 30 more seconds. Yes, any answers, Kana? Okay, fine. So your point for this question will become 1.75. Anybody else wants to answer? It's an open question now. Right? Anybody wants to give me an insight of this?
The air from atmosphere will replace the reduced oxygen.
Yes, yes, yes. So what happens is once the reduction happens by SO2, say the flower is there, it is still exposed to atmosphere. Say oxygen can come, right? And it can get oxidized again. Right? So basically oxidized means what? It is going to the original form. Original form means colored form. Very simple. Right? Now already it is now in case of Cl2, it is by oxidation. So it is permanent because no more further oxidation can happen even if it is exposed. Right? But SO2 bleaches by reduction. Right? And now still it is open to the atmosphere. So it can react with oxygen and get oxidized and it goes back to your original color. That is why it is temporary. Yes, Kana, understood group 1? How you have to answer this question?
Yes, sir.
Right, good, good. Right, anyways, a good attempt. I didn't expect you to answer this question, but anyways, you answered. Very good. Right. Okay. Next question is for group 2. Group 2. Okay. Perchloric acid is, perchloric acid is stronger than sulfuric acid, that is H2SO4. Why? Okay, perchloric acid is stronger acid than sulfuric acid, that is H2SO4. You have to give me a reason, right? And guys, I'll be back in a minute. You think about the answer group 2, and I'll be back in a minute. Yes, people, I'm back. If you're ready, you can answer, or you still have one more minute. Yes, any answers group 2?
Sir, is it because of the oxidation state?
Okay, go on.
In Cl and perchloric acid, its oxidation state will be
One second. What is the formula for perchloric acid? Perchloric acid, what is the formula?
HClO4, sir.
Okay, fine. Now you talk. Yeah, continue.
Sir, so the oxidation state of Cl will be +7.
Okay.
But in sulfuric acid, H2SO4, it is +6.
Okay.
So since the oxidation state is greater, it can readily be OH bond. So acidic strength will be more.
Okay, fine. Your answer is correct. Right. So, guys, what you have to understand, okay, there are two reasons to this. One, this is the obvious reason. Okay. First reason is chlorine is more electronegative than sulfur. That is first reason. Okay. Second reason is this, what she told. Now, here in this thing, I'm going to have +7 oxidation state, but in H2SO4 for sulfur, I have only +6 oxidation. Remember, acidic strength is directly proportional to the oxidation state. More and more is the oxidation state, more and more will be the acidic strength. Now that same goes with this. Say if I ask you to arrange HCl, HClO, HClO2 and HClO3, right? Now this will be the order of acidic strength, because you see here it is -1, here it is +3, here it is +5, here it is +7 if you calculate, right? So more and more is the oxidation state of chlorine, right? Or whatever be the element, more and more will be the acidic strength. That's what you have to understand. Okay, good. Your points. Right. Group 3, your question coming up. Okay. So group 3, I have HClO4, HClO3, HClO2, and HClO or HOCl, however you want to call it. This is HOCl if you want. Okay. Arrange them in the order of oxidizing power. And why? Obviously, you have to give me the reason. Right? Arrange them in the order of oxidizing powers, right? And give me the reason for this. That's your question. Group 3.
The last compound you wrote is HOCl.
Sorry.
The
Can I come
last
again?
compound is HOCl. The last compound.
I'm sorry, I'm not able to hear. What happened?
The last compound is HOCl. Right?
HOCl. Yeah. Last compound is HOCl. Yes. Or HClO, however you want to call it. But actually, chlorine is in the middle, so it is HClO. It's better to call it as HClO. It's better to call it like this.
Sir?
Yeah.
Sir, I think the order should be HOCl4, HClO4 should be lesser than HClO3, which is lesser than HClO2, which is lesser than HOCl.
Okay, fine. So HOCl is the greatest. Why?
Yes. Sir, it's because of the oxidation state, sir. HOCl4 has like the order of oxidation states is 7.
Okay.
And 5,
okay,
3, and 1,
Okay.
sir. Because HClO has the lowest oxidation state, it has a higher tendency to get oxidized, sir. So,
absolutely.
and
Absolutely.
hence,
Absolutely true. Very good. Very good. So it's very simple, right? Now from +1, it can easily go to higher oxidation state. It can go to +3. It can go to +5. It can go to +7. Right? So obviously this can undergo this can undergo once again. It can undergo oxidation. So it should be reducing agent. What is wrong? But +7 can easily undergo reduction to +5, +3, and +7. So it should be the strongest oxidizing agent, right? But why this thing is like this? 1 second, guys, hold on.
sir, oxidizing power means the tendency to get oxidized, sir.
No. Oxidizing power means power to be an oxidizing agent.
So even then HOCl has +1.
1 second, 1 second. Just wait. Okay, the answer is correct. And we have to speak in terms of oxidizing power. Okay, for now, I'll give you the mark, but I'll clarify this. Okay, right? I will clarify this particular question. But yeah, this is the order. And yeah, but +1 can, I will clarify this. Okay, right? How is it like this? I'll clarify. Okay, for now, I'm going to give you the mark. Okay, right. Next question for group 4. Group 4, your question is complete this particular reaction. I2 plus H2O plus Cl2. Complete this reaction. Oh, no. Wait. Okay. Yeah, now it's fine.
One minute.
Yeah.
Sir,
Yeah.
sir, is it 4HI plus 2ClO2?
Sorry.
4HI plus 2.
Oh, that is HOI.
No, sir, 4HI.
4HI. Okay. HI plus
2ClO2.
2Cl.
O2.
ClO2. ClO2, first of all, the compound exists. Are you sure? I'll give you 30 more seconds to give me the correct answer.
So HCl is formed.
What?
HCl is formed in this compound, sir.
HClO7.
Not HClO7, sir. Only HCl.
Only HCl. Okay, fine.
Along
Only
with
HCl.
another compound.
Okay, HCl is okay. Another one.
Few
This
more
is wrong.
minutes, sir. With IHO, sir.
IHO. That means HOI.
Yes, sir. It will have HI and O.
Okay, fine. I will give you 1.5 for this. Right? The correct answer is HiO3 plus HCl. This is the answer. Okay? HiO3 plus HCl.
How did we
That's
get
correct.
that actually, sir?
Sorry.
How did the reaction take place? How did it become?
Nothing. So all you have to understand is when chlorine is there, chlorine can act as oxidizing agent. Okay. So basically what do you expect to form is HI. Okay. And HI will be oxidized to HiO3. That's what will happen. Okay. And HOI is little unstable. Okay. Compared to HiO3, HOI is comparatively unstable. Okay. So that's why it's going for HiO3.
Okay, sir.
Okay. Right. Good. Fine. Next question goes to group 1. Okay. So question for group 1 is chlorine plus BaOH twice, which is hot and concentrated. What will happen? This question is supposed to be easy question, given I forgot that I actually asked it in another way, but still it's fine. You can tell me the answer. Yes, any answers? Group 1.
Sir, it will form barium chloride,
Okay, barium chloride formula.
BaCl twice.
Okay, BaCl2, not twice. Okay, then plus Only one
H2O.
compound?
H2O.
Okay. H2O, there is one more. If you can remember what happened with NaOH when it was hot and concentrated, the same thing will happen for this. Okay. Just that the base is different. Here it is BaOH twice, here it is NaOH. That's the difference. But same kind of product you will get. I'll give you 20 more seconds. Yes, any answers, group one? Okay, last guess. Anything you want to guess randomly?
Sir, maybe HCl or barium oxide.
No. Okay, I'll give you 1.5. Okay, right. Okay, I can give you actually 1.75. Right. So 1.75, what is missing? Anybody wants to tell me what is missing? Open question. If NaOH, okay, what?
BaCl2 plus BaClO3 twice plus H2O.
Right. This is what is missing, right? Barium chlorate. It is. Same thing happened with NaOH, if you can remember. NaOH, hot and concentrated, right? Plus Cl2, what happened? NaCl, NaClO3 plus what happened? H2O. Now, if this was cold and dilute, the only difference is here I'm going to form NaOCl instead of NaClO3. All the other two will remain same. Okay, right? So yeah, that's about that. Okay, next question for group 2. Okay, question is addition of Cl2 to Ki solution, right, gives it brown color. Okay, but when excess chlorine is used, right, it becomes colorless, right? Yeah. What exactly is happening here? Explain this in the form of equations to me. Right, once I add chlorine in little amount, the Ka solution turns brown. But if I add excess amount of chlorine, large amount of chlorine, it is going to go back to colorless solution. Why? This is group 2's question, right? Yeah, group 2 question.
Sir?
Any answers, group 2?
Sir?
Yeah, tell me, Gana.
I'm not sure, but I think it's because of at first chlorine will oxidize.
Tell me the reaction.
So Ki plus Cl2 will give KCl plus I2. So I2
Okay.
will give the brown color.
Okay, fine. This is brown. Okay.
So when we add excess of chlorine,
Hmm.
it will further get oxidized and it'll give iodic acid HiO3. So
Can you tell me the reaction?
Cl2 plus I2 plus H2O will give HCl plus HiO3.
Okay. Fine. Man, this is
So
going to
this
be
one will give
colorless.
colorless.
Okay. Good attempt. Very good attempt. Very, very novel way of thinking, right? But first one is right. Okay. Even though, like, say, I can understand why you thought like this, because Ki is an aqueous solution, right? So Cl2 plus I2H2 reaction we saw, it's a very good attempt, very good way of thinking, right? But sometimes that is not enough. But just for your thinking, right? I'm going to give you 2 marks. Okay. But the real answer is when I have I2, it is brown color. But when I have excess amount of chlorine, Cl2 and chlorine will react to form ICl3. This is going to become colorless. Okay, this I2 which is formed will react with excess chlorine to form ICl3. ICl3 is going to be colorless. That is the exact answer. But a very good attempt. This is a very good way of thinking. Just because of that, I'm giving you the mark. Okay, so don't expect to happen in your exams. Okay, this is just an appreciation. Okay, right. Moving on to next question for group 3. Justify the fact that O3 is a strong oxidizing agent. Basically, we have to give reason for this. Okay, justify this statement. Group 3, a question. Yes, any answers, group 3? Yeah.
Sir, O3 is a powerful oxidizing agent because, sir, because O3 is not a very stable compound, sir.
Okay.
So because of it, it easily gets decomposed to O2 and nascent oxygen, sir.
Okay.
And
Okay.
nascent oxygen is a free radical compound. So
Nascent oxygen is
free radical.
Free radical. Okay, okay, understood, understood. So yeah, the answer is correct. So whenever I'm going to produce this nascent oxygen, whichever can produce this nascent oxygen will be a strong oxidizing agent. It's very simple because this O will be the form of a radical, as he told. It will be highly reactive, right? Highly reactive. So I know, as I said, ozone is little unstable, right? So O3. 1 second, guys. There is so much noise. Okay, now is it fine? Right. Okay. So O3 will dissociate to form oxygen and this nascent oxygen. That is O2 and nascent oxygen. And this is the reason why it's a very strong oxidizing agent. One of the most powerful oxidizing agents you can have in chemistry is O3. Okay, good. You're going to give me the points. Group 3 gets +2. Right. Group 4, your question on the way. What should I ask you? Wait. Okay. Tell me this. P4O10. Give me the structure. Send me in WhatsApp. P4O10. I want the structure.
So do we have to draw the structure or?
Yes, yes. I will draw the structure. Either show me in the video or send me in WhatsApp. Yes, ready?
1 minute.
Okay.
So I sent it in WhatsApp. So what I think is listed.
P4O10. Mhm. Okay. Not a, like say, clear picture, but I understood what you're trying to say. Yeah, what you've done is right. Okay, I'll give you the points. So class 2, 4, group 4. So this is how the structure looks, people. So what you do is for P4O10, you first draw 4 P's at 4 corners. And in between the P's, you put this thing, right? And for each of the P's, you put a double bond rule. Okay, now connect. Okay, right. Now what you're going to do is between this P and this P, put an oxygen, and between this P and this P, put an oxygen. That's very simple. This is what is P4O10. Okay, first what you did, you draw 4 P's, and in between the P's, you put oxygen, and for each of the phosphorus, you put double bonds, and between this phosphorus and this phosphorus, that is this and this, and between this and this, put an oxygen. That's it, P4O10. Right, good. Fine. So we have almost finished everything, right? We have done all the possible questions. Right? There might be still more questions. Questions are endless, right? But we have covered all the possible concepts of group 15, 16, and 17, right? And remember, for group 18, we are not going to have a quiz. I'll just tell you what to study. Okay, study about the structures, xenon fluorides. Right, that is XCF4, XCF6, XCO2F2, XCO3, XCOF4. Like this, they can have different compounds of xenon. Okay, know their structure. Right. Next thing is hydrolysis. Hydrolysis of xenon fluoride. Say, for example, if XCF4 reacts with water, or say XCO2F2 reacts with water, what are the products? Something like that, right? So know all the reactions of xenon fluorides and know all the structures of xenon fluorides. That is enough. That is enough for group 18. Okay, so successfully we have completed your P block, and in that way the quiz comes to an end. Okay, the quiz comes to an end. And I want to know, other chemistry sir, what is he teaching now? Did he start any new chapter after solid state? He was, I don't, lastly he was teaching solid state. Did he start anything after that?
No, sir. Please,
Okay, so which chapter you want to start? You want to start with coordination compounds
biomolecules.
biomolecule.
Biomolecules?
First
Okay. Fine. Right. So we'll start with biomolecules next class. Right. So totaling up, see, like the who wins, who loses here doesn't matter. All of you played very well. Okay. All of you prepared. All of you gave answers. Right. All of you tried your level best. This quiz is not because of who's winning and who's losing. It's all about everybody. The whole point is that I hope that everybody has taken down every question asked in this quiz, not only your own questions. Okay. If you have done that, you got benefited. Right? Not because you won the quiz. Okay, if you have taken down all the questions and all the answers are given for all the groups, then you got benefited. That is what is the whole point, right? Who wins, who loses really doesn't matter. But still, since for the sake of it, we'll calculate, right? So 18 plus 1.75 plus 1.75 is how much? 3.5,
Excuse
right?
me, sir.
Yeah, tell me.
Could you repeat what we have studied in group 18?
Yeah, group 18, where did I write? Xenon, you study only about xenon fluorides or xenon oxyfluorides. There are two types of fluorides. Xenon fluorides only contains fluorine, and the other thing is xenon oxyfluoride, like say XCOF4, XCO2F2, something like that. You have to know their structure and their reaction with water. That's it. These two alone you remember, nothing else.
Okay.
Okay, Rohan. Right. So it is 16 plus 18, 8 plus 2 is 18, 18 plus 3.5 will become 21.5. That has group 17. Sorry, group 17, I'm telling so much this thing. Okay, group 1. So now it is 19.75 plus 2 will become 21.75, right? And here 22, 24, 25, 27, 29 for this thing for group 3. And for this thing, 20.75, 24.75, 25.25, 26.25 for this thing for group 4, right? So there is not much difference here, right? But still, group 3 has highest points. Okay, but there is not much difference here. All like 4 points, 5 points, to a matter of 2-3 questions is what is the difference here. Okay, fine. All of you, well played. I'm really happy that everybody participated very nicely. Everybody prepared and really came. Okay, I'm really happy that you all took your efforts, right? And then these efforts are not going to go waste, right? And people, if you have not taken down every question for every group, see who has taken it and please take down the questions and the answers, obviously. Okay, it is going to be really helpful. Only the questions which are there when we only the questions which we have discussed, that alone you prepare, and obviously your NCERT book back exercises, right? Your NCERT book back exercises plus we have solved most of the questions from NCERT also, right? So this plus the remaining questions in your NCERT book back and your in-text questions, you are set. You don't have to study P block. Please do not go through the big chapter by studying. It is waste of time. That is why I already asked you to study. Now you answer the questions. Now you study only the questions for P block. Okay, this is how you prepare for the exam. If you're going to study the chapter again and again and again, it is going to be waste of time. Again, I'm repeating you. Okay, any questions anybody has? That's it from me today. Any questions anybody has? Okay, fine. Thank you so much, people. We'll meet again next week. We'll start with biomolecules as you asked for me. Okay, fine. Thank you so much.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.